So, and also we are receiving other documents, like one of is this marshalling box GA drawing team. This is also one more drawing we will receive from the vendor, from the manufacturer. So we have to also, this is for just for our information. So how it looks, all these things you can see in this. So these are all the general drawings you can see in the from the manufacturer team. So apart from this, this is the main one. Again, one more important scheme that we have to review whether all the connections, everything is perfectly given or not. So obviously, all these schemes, everything are standard one thing. So there is a no choice of no reason of review, but for our just to check whether by copying and pasting the things, whether any changes have happened. Those are the things generally we will check apart from this. So remaining all will be the quite fine. So now let's see how the scheme works, team. So marshalling box, see, this is the general for PPT I given here. Anyway, I'm sharing you the normal good quality drawings in the drive link. So for presentation, I posted here. So when I'm putting that, the quality has gone down. Fine. So let's talk about the scheme here, team. Let's say minute. So simple, team. I think you are already familiar with the things, but again, this scheme again we are discussing in our control and protection. Just for your, I want to I want to explain here also the scheme. Let's see, team. So as I said, this is my isolator. I'm having three limbs for each face: R face, Y face. This is the Y face, and this is the B face. This is the, I'm talking about the double brake isolator. So this is the blade, team. This is the blade connection. And this is the incoming side, and this is the outgoing side. Now let's see, first of all, let's talk about the operation of this isolator, team. So how about to do this isolator, how to open this isolator? The isolator, this is in the closed position. Now I want to open these blades to be moved in this direction. All the three blades should be moved in this direction, right? Blades are moving in this direction. So to move these blades, so after opening, the blades after opening, the blades will be in this position. This position. And again, to close, this is the way of close. This is the way of close. So now what I am doing, I want to rotate this blade. I want to rotate this blade some 90 degrees. And again, I want to rotate it back 90 degrees to close. To open, I am rotating 90 degrees and clockwise, and to close, I am rotating anti-clockwise. So this is the way of doing. So to rotate this blade, I need a shaft. All right. I need some shaft, some pipe. So I am arranging a one pipe from here, a pipe here. All this pipe is connected to all this. I mean, this is a tandem pipe, what we call this tandem pipe. And this tandem pipe, what I'm doing is I connected to all this to the center. So, and I am connected this to the shaft, team, to the shaft. So now let's assume if a person standing here, and if he is rotating this shaft like this, rotating this using some handle, so all the blades will be open. And if he is rotating in this direction, whatever it may be, you can vice versa, then the blades will be closed. So this is the mechanical operation. This is the mechanical operation. And now I don't want to see, I don't, every time the person going there and sitting. So I don't want this. I want total unmanned operation in my system. So for this, what I want to do is I want to establish a electrical circuitry for this. To provide electrical circuitry for this, what I'm doing, so this shaft, I will connect to a motor team. I will connect to a motor. And now what I will do, I will rotate this motor with some supply. So I am giving three-phase supply. This is the R phase, and I am giving the Y phase and the B phase, RYB supply. I am giving to this motor, to the R terminal, Y terminal, and the B terminal. So motor will rotate. So when the motor rotates, the shaft will rotate. When the shaft will rotate, this, so this, all these blades will be rotated. Good. Well, so now again, if I want to rotate, this is for opening, it's fine. Now I want to rotate the motor in the reverse direction. So my shaft will rotate in the reverse direction. So now blades will be now, before it is open, now blades will be closed. Then how to rotate this motor? So I will select a squirrel cage induction motor where any, if you change the phase reversal, the motor will rotate in anti-clockwise direction. This we already know. So what I will do is, I will change the phases. How? I will give R phase to the Y phase and Y phase to the B phase. Sorry, Y phase to the R phase. And B phase will be B phase. So this is the open condition. To close. Or whatever it may be. This is for open. If it is open, this is closed. If it is closed, it is open. Say. So when I'm doing this phase reversal, so this is happening. Now, again, who will do this phase reversal? So I have to place some switches that should be automatically done when I am switching it on. So what I will do is, I am having a switch here, which is a closed switch, and I am having an open switch. This is the open switch. When this switch is, when I press this switch, so I am giving a DC supply to this switch thing, to this switch. So, and I am providing a DC supply to the open switch also. So for the closed switch, let's first talk about the closed switch. When the closed switch is on, then I will take a coil here, which is closing coil, which is a closing coil. When the closing coil is energized, this is a negative supply coming from this and connecting directly to the closing coil. When the closing coil is energized, then it is having some respective contacts, like it is having some respective contacts. All are NO contacts. All are NO contacts. So when this energized, all these contacts are closed. So now what I will do is, I will give the motor supply to this coil, R phase, Y phase, and B phase. And this B phase is connected to here, and R phase is connected to here, and Y phase is connected to here. So whenever a closing coil, when you are issuing a closing coil, this closing coil will energize it. When it energizes it, so these contacts will be closed. So when these contacts will be closed, the supply is extending to the motor and motor is closing. Fine. And then I come to the next part. which is opening coil. I am giving a opening coil, and for this opening coil again the negative supply is extended negative, and for this again I am having the contacts. Similarly. So if these are there, then this supply will extend it. Now I will give Y supply to here and B supply to like that. So whenever a closing coil is energized, isolator will be closed. Whenever an open coil is energized, isolator will be opened. So this is a simple scheme drawing. This is a simple scheme drawing. Now, let's see this way. So when I am closing the coil, when I am closing the isolator, when the closing coil is energized, the motor supply is directly hitting to this motor. So how much time it will be there? How much time it will be continued? So the motor supply continuously. So the motor is rotating too. So the blade will rotate only, direct rotating only. So there should be some limit switches to be placed in. So I am having a limit switches at this head here, and I am having some limit switches when I am opening this. When this blade is hitting to this limit switch, then this will be opened up. These will be opened up by when I am hitting to the limit switch. Similarly, after the opening, when this blade come to this position, again I am placing some limit switch. When the limit switch is hit, again this opening coil will the supply will lost for this opening coil. So that is the way of doing. So this is the one more feature of limit switch I am adding here. And again, now the isolator is an equipment which should be operated in no load condition. And we have to ensure, because a person who don't know about the system may operate the isolator accidentally and may leads to the fatal accident. So I have to give arrange some kind of interlock to ensure the safety of human and also to ensure the safety of equipment. So what I have to do? I have to consider some conditions. When these conditions are met, then I am closing the closing coil. When some conditions met, then I will open up the isolator. So the closing of the isolator, opening of the isolator, always to be done when you see the interlocks, when you see the status of the breaker. The breaker status. The breaker close, open. Earth switch, open, close. The breaker, let's see team. The breaker is there. I said before, I am having an isolator here and a breaker here in our SLD if you see, and a CT here, and again the isolator here, and the lightning arrestor and connecting to the line. So this is the one. So when I open this, when I want to open these isolators, I have to open up this breaker and upstream breakers. So the breaker should be in open position. When you are opening the isolator, you have to see that my breaker should be open position. So breaker indication to be considered here. So what I'm doing is, this positive supply, I will not directly give to the closing switch. I will take this switch to the breaker and I will check the condition there. Whether the breaker is closed, then again the supply will extend it up to here. Similarly, again it will go and it will check the earth switch condition and again it will back. So if these two conditions met, then this positive supply will be extended to the closing coil. As well as when you are opening the isolator, the same condition, So this is the same condition will go. Though, so these will called as a interlocks. Interlock. So interlock condition also we have to add. And apart from this interlock condition, now where you are opening or closing this isolator, isolator can be operated at three stages: at field level, at Scada level, means local, remote, means local operation of the isolator, remote operation of the isolator. What is mean by local operation is, the local operation is a person standing in front of the isolator and opening the marshalling box, and when he is pushing this close button, that reflects the local operation. Or else in the local operation, again two are there. One is the electrical operation, one is the mechanical operation. One is the electrical operation, one is the mechanical operation. If a person pressing this button, this condition satisfied, so it is operating. So this is electrical operation. Or else the person in the isolator marshalling box, he will provide one one L-shape handle. So if you insert that handle, if you rotate, you can operate the isolator without electric connection mechanically. That is a mechanical operation. So isolators can be operated in the local mode with two ways, electrically or mechanically. Come to the second day operation, which is the remote operation. Remote operation is only electrical operation where a person sitting in front of the system and he is hitting the close command from the Scada. From there, the status is coming here and the isolator is opening or closing. That is a remote operation. So these are the two operations. So again, if you want to specify where you want to open, where you want to see the local operation or remote operation, that also you have to add before this closing switch. That is the whether you want to operate the isolator locally or remote. Selector switch. This is the selector switch. This is the selector switch. And apart from this three, again we are having one more is, that is a mechanical interlock. That is, when you are operating the isolator in the electrical operation, mechanical operation should be avoided. And if you are attending the mechanical operation, electrical operation should be avoided. So that interlock also be taken care. That is taken care by a key. A key will be there that we will insert here to get the mechanical operation. If you remove the key, it will electrical operation will be there. So it is vice versa, what it may be. So some interlock condition will be a key for mechanical operation. So all these conditions, all this circuit will give a final isolator drawing circuit team. So this is the one. Let's have some questions here. Are these mechanical or electrical interlocks? Yes. Understand is only electrical interlock. Yes, these are the electrical interlocks. As I said, now the key arrangement, that is a mechanical interlock. I will show you this in the circuit. So this is the whole picture of isolator team. So again, now once again, I just want to recap in a brief. Let's see. My isolator should be operated open or close. To open or close, I am providing a motor supply. And when I am changing the phase reversals, the isolator will open or close. So for this, I require a closing coil and opening coil. Those contacts I am using for is to make it an automated way. Again, we are having some, we need to give, we are having some interlocks. The breaker switches interlocks, those to be taken care before you closing, if you are operating the isolator. So those things also to be added in the circuitry. And also the isolators can be operated from local or remote. So those conditions also to be considered. And finally, the mechanical interlocks also to be taken care when you are operating this isolator. So apart from all this, tomorrow, I want some status from this isolator, whether my isolator DC supply, mechanical control box supply, means DC supply is healthy or not, or whether the isolator is operating in local or remote. So many isolators will be in the remote. So how can I know that whether this isolator is operating in remote or local? So those conditions, or isolator open or close conditions. So all these conditions I required in my Scada. that we are seeing in our control and protection classes as a terms like BI, binary inputs for my BCPU, by control protection unit. So we can see all these statuses indications. So for this, again, we ask a provision or a spare contacts from the manufacturer here to get a more reliable thing. So let's go back to our actual thing. So any doubts you can ask team. Meanwhile, I'm just going to back. So any doubts you can ask. Can you please explain how these electrical interlocks function here to ensure safe switching? Yes, sir. See, when the breaker is in close, when you are operating the isolators are operating in load condition. So isolators are not are exposed to the atmosphere. So it is not having any medium to quench that arc when it is opening in the load. So that may lead to the damage of nearby equipment or the person who is attending there. So we have to check some conditions to do this. And when you are closing the isolator, you have to ensure that a switch should be in open position. If you are closing the isolator and a switch is closed, it's creating a short. What short? LG fault. You are creating a ground. Directly, the live is connecting to the ground. A huge ground fault. So these are some interlocks for safety for isolator thing. Clear? Meanwhile, I will open the isolator drawing. Where is? So, any doubts, team? Any doubts, please? First of all, is it clear to you, team? Yes, no? Yeah, perfect. Cool. Yes, let me share you my screen, team. Where I place this, sorry. Yeah. So, are you able to see my screen, team? A picture, a drawing. Yes, right. Okay. Cool. So now let's see the operation of the isolator team, close operation. Let's follow me. So this is all. Now I am seeing the close operation. This is the positive supply. This is the negative supply. Let's see the positive supply. Positive supply is going out and checking the breaker interlock and checking the head switch interlock. These are the two interlocks. And now, if the key is inserted, if the key is there, then this is will be on. So this is the mechanical interlock. This is the mechanical interlock. And this is some overload switch, emergency push button. And it is appearing up to the local or remote. Now let's see in the close. First we'll see close local operation. Means the person standing in front of the isolator and he pushing the close button. Local operation team. So local. So I'm selecting this local. So what I'm doing now, close. So this push button, you are pressing this push button. When you are pushing this push button, the supply is going like this. This C, it is hitting the limit switch. And it is connected to the closing coil. And the negative supply is coming this side and directly it is connected to the closing coil. Now the closing coil is energized. When the closing coil is energized, then always the supply will be there, the RYB supply for the motor. Now by this closing coil when it is switched on. So all these contacts will be made. This is the closing coil contacts team. So R phase is connecting to the R phase, Y phase is connecting to the Y phase, and B phase is connecting to the B phase. So the motor is operating in the clockwise direction. Clockwise direction. So this is the closing operation in the local. Now suppose if you want to operate the close command, close operation from the remote. So from the remote, this is the where you are giving the closing command team 13. Tomorrow, when I'm explaining about the schematics, there you can see this terminal box TB1 13th terminal I am using in the scheme for closing of this isolator. I will focus here there again. So there is a no, all the interlocks already, it checked all the interlocks in the BCPU, whether there it is a soft logics or hard logics. So it is already taken care there, and the signal itself is coming here and directly going like this again. Simple, same. So this is the close remote operation. And now let's see open operation team. I am drawing the open operation, the green color. Again, see the positive supply, all the checkings come to here. So from here it will change it. It is connecting the open. Now you are pushing the open button. When you are pushing the open button, this is the one. Open coil is energized, and negative supply is coming from this. When the opening coil is energized, then the supply R phase is C. Now these coils are will be closed. Now R phase is connected to the Y phase, and Y phase is connected to the R phase, and B phase would be the P phase. So this is the open local, and open remote directly from the 12th terminal you are giving the signal. Same it is doing as we are seeing. So this is the operation of the isolator. And apart from this, other things we have to consider that. Now, as I said, whether the isolator is local or remote. So the status I am taking, if it is local, this is the status I will get to the Scada. And if it is remote, this is the Scada thing. And also, this is the panel inside the marshalling box for tomorrow. If I want to see any maintenance or soldering works, this is the sockets where I am using there. And these are the auxiliary switches for my to know the status of the isolator, and to know that this is again the Scada interference to check the whether my the MCB, which is the DC supply, is healthy or not. That is this from this Scada I am taking it out. This we will you will get a clarity on this when I am talking schematics in our control and protection. Again, we are talking about this drawing, but from where we have to pick this for this function. So there we are seeing that. So in that you can easily understood what actually it states. Fine. So this is the circuit for the isolator team. Now, do you have any other things? Suppose if you are having a large network and if you want to know this isolator indications to be given to the next breakers. Suppose if you are implementing the 1.5 breaker scheme in the 33 kV system, let's suppose, then the isolators are more. And for the breakers, you have to take the all isolators, status, everything. So it's complex. So there, these number of contacts will not be sufficient for you. Then you have to ask the manufacturer that, could you please provide the additional contacts as per my requirement? Again, whether he may agree with the same cost or with a cost implication. Two things will be there. It depends upon how you are bargaining with him. So this is about the circuit of my isolator team. So any doubts? Any doubts? So that is for today, and I want to show you the video of this. Meanwhile, I just want to open the video. So if you have any doubts, you can ask him meanwhile. So I'm just I want to show you how it is operating. disconnector. Owning the yeah. Hello, friend. Welcome. Let's see this team. Just for your this, I'm sharing you this. So, are you able to see this video, team? Technical demonstration. Hello, team. Are you able to see the video? No. Yes. Yeah. Okay. So now let's see, team. My isolator is in open condition, team. See my blade. See how the blades are moving close. So this closing. So isolators, this is a devil break. The isolators touching to the blades and it twisting. If you just clearly observe, it is the isolators blades are entering into that hole in that area and they are twist. So we have to again mention a point that my blade should hit that one and turn and twist arrangement. Means it is turn and twist to make it a lock inside that to avoid the arcs. So this is my marshalling box, team. Again, back. So this is the lever. This is the rod. So if I rotate this rod, the isolators will be open or closed. This is the mechanical operation, team. And come inside. So I placed already the switch here. So this is a control board. As I said, we are having a close switch, open switch, and overload emergency push buttons. And this is for local or remote selector switch. And this is for mechanical interlock. And this is the motor, team. Sorry, this is the lever. Our motor is inside it. So this is the motor. And this is the shaft connecting to that thing, team. So this is the, as I said, we are having some for closing coil, opening coil. So these are the two things: closing, opening coil contacts. And this is connecting to a vertical rod. This is will called as a tandem pipe, which is made with hard drawn electrolytic copper. And this is a control board, MCBs. So he's showing the some things here. So this is the connections RYB inside to the motor. This is the auxiliary switch. Levers. This is the handle for the manual operation. So wait a minute, team. One more is there. This is the video, I believe. Let's see, team. This how is operating the isolator. So this is the 33 kV isolator, team. So again, this is the marshalling box. So he's doing the mechanical operation, I think. So he's placing that in there and he has to rotate this. So before that, he is checking whether all the things are fine or not. So this is a selector switch. In some manufacturers it would be that, in some manufacturers it should be different. The switch is placed. Now he is removing the key. So after removing the key, he is putting the key here. See, now he's putting the key here. Now if we put the key here, then this will be opened up. Then this will be we will get a provision to make this one to connect with that, and now you can do the mechanical operation. So this is a kind of interlock for both mechanical and electrical thinking. So now you can see the isolator is operating in manual operation team. See, those are closing. Yes, see, you can see here the isolators, if you just clearly see, so what, see, they just came in horizontal and they finally turned into the 90 degrees. Before they are coming in normal direction, turning and twist. So this arrangement we will call as a turn and twist arrangement. So that is the main thing here, team. And now again, he is doing the electrical operation. He removed the key and he is placing the key. So when he is placing the key, the circuit will through. There, the key is there, so the switch will be there. Now he is opening the isolator. So when he press the button, see, the isolators are opened. So this is the electrical operation team. And by pressing the green button, the isolators are closing. And this is the local remote. So you already know this. So any doubts, team? So you got an idea how to operate the isolator and whole circuitry of the isolator. Yeah. Team, yes, no, please. Okay, that's great. So team, always I will try to show you that breaker isolator operations, because some will be in some imagination, even though we are having, see, myself, which you see, I'm having this much. Sometimes I will confuse with my spring charge and this sometimes because we are having so many things in the mind. Sometimes for for small things also we are not much we are not putting much on that. So it is obviously good way to see the basics things also. So I am moving in that direction only. How it is connected to SCADA? Yes, sir. So this is now connected to my CRP panel. In the CRP panel, these signals all be directed to the BCPU, which is a Bay Control Protection Unit. From the Bay Control Protection Unit, a FO cable to be run to the SCADAs. There I will show you that. And I'm explaining when I explain in the schematic drawings, I will show you there. Okay, team.